Hello, my name is Bryce Hill. In this video, we're going to be going over a lesson plan that involves basic geometric shapes. We're going to define, list, and memorize common two-dimensional shapes. Here's our Georgia standard. To read, we're going to find area of the right triangles and other triangles, quadrilaterals, polygons, by composing into rectangles or decomposing into triangles and other shapes. We're going to apply these techniques in the context of solving real-world and mathematical problems. Here's the reference below. Here's our corresponding Common Core reference. So here's our rationale for our lesson plan. Again, we're going to define, list, and memorize common 2D shapes. Pretty much what we're going to do, we're going to have the children use GoogleDocs or any other software that will allow a student to create images on documents as a way to help students recognize and recall geometric shapes, or their components by definition, labeling, illustration, or by symbols. To continue, here's our main objective. Students will, 1, recognize and be able to recall the names and components of the most common two-dimensional shapes. Our secondary objective is to have students create their own study material either with low-tech flashcards or high-tech PC or online software to define, list, memorize common two-dimensional geometric shapes. We want to first see what knowledge students might be bringing into the lesson, so here we begin with a pre-assessment. We call this a formative assessment to gauge the level of prior knowledge. Here's a link right here to the Google Doc. And we'll ask them questions like this. If two geometric figures have the same measure, they are said to be what? A figure formed by two rays with a common endpoint is known as what? Identify the object labeled in the image below. The symbol of A, B, with an arrow to the right is known as blank AB. Geometry is based on these undefined words, which are it divides the segment into two equal lengths. Find the term. The symbol for blank is a small raised circle. Part of a line is known as what? This figure has two endpoints. Angles whose measures are greater than 0 degrees but less than 90 degrees. A geometric figure that is made up of at least 2 points. It has no width or depth, yet extends to infinity in both directions. Angles whose measures are 90 degrees. Identify the object labeled in the image below. The symbol AB with a line with arrows on both ends is read as blank AB. Can you give another name to this object? Identify the object labeled in the image below. The symbol with AB and a line across the top is read as blank AB. Angle whose measures are greater than 90 degrees but less than 80 degrees. Angle whose measures are 180 degrees. So after the children take, or the students take, the pre-assessment, you'll have a pretty good idea of what prior knowledge the children bring into the lesson. This will help you form your lesson a little better. Now this lesson is broken up into different parts to allow you to differentiate if you need to, based on the kids' prior knowledge. Here's our main activity. Part 1. Students are to identify and define the components that make up a plane, a line segment, an endpoint, a midpoint, a vertex or vertices, a ray, a leg, define congruent, and define an angle. Here's the link to the main lesson. Now let me show you how I want to give this document to my students. Here's my Google Documents. I'm going to go up here to the send, and you can very easily email this document just by typing in an email and sending them this link. Now you can shorten the link if you want to, but I want to send this to all my students and tell them once they've received the document in their email to save it, as I'm showing you how to save it here, as their own document, as so. That way, as they make changes to the document, it'll be in their files. Now let's discuss engagement. We're going to have students discuss the ways they retain information. Metacognition is what we call it. You can show students some examples if you like, but for right now, we're going to have them investigate this through the engineering design challenge. The engineering design challenge is what we're going to do is design a document, image, or slide presentation that can be used to help them remember names and components of common 2D geometric shapes. The constraints you may have to deal with: some may not understand abstract explanations. You may not have access to a computer. Like I said, you can use flashcards if you don't have access to a computer, way to differentiate. Or you might have students who are not computer literate, which means you might have to take more time to teach them other computer skills within this lesson or before this lesson. Moving on to the next aspect of this lesson plan, we're going to go over exploring. This is where we provide each student, if they have computer access, with Microsoft Office Suite or Google Docs or any software that can create images within a document. We're going to discuss the designs that the students may want to use for their project. Tell students they will have another opportunity to redesign at the end of the project. We're going to allow the students to discuss what type of meaning they might want to convey through their work. We want to try our best to lead them in their creative process by selecting features they can use to create an image, again, within a document when using Microsoft Office Suite, Google Docs, or other software. This is in line with our engineering design process. Have them brainstorm and then allow them to redesign. After exploring or creating their work, we're going to go through explain and connections. Here is where we have children find shapes they have learned about in this lesson in the real world and explain their understanding of that shape and its functionality. After we've had our pre-test, we move into the lesson. If you would like, you could have a lecture before this and use this as a review. But right here, we're just moving through the questions, and you can have the kids answer of, as a class, either looking through their book or pulling their knowledge from memory. But here's the part where the engineering design comes. We're going to come up on one of the questions where the students are allowed to enter their own images. Here we are. A geometric figure that is made up of at least 2 points that has no width or depth yet extends to infinity. You can have them click this image and you can search through Google, or you could use images that you've uploaded to their computer. And it's good to type out to see what images come up so you're not surprised in class. Boom, here's a perfect image of a line. We allow the students to insert that. Now, this is the part that we're engaging, is we're allowing the students to create their documents to help them to remember names and components of the 2D figures. Here's another place the kids have an opportunity to insert their own image. Again, they can insert their own image with a camera, or they can use the Google images. Again, as a teacher, you want to type in to make sure you get the exact figure that you want and you're not surprised in class. This is about the perfect example right now we have for a plane. If you want a better one, you again can save one for the kids, but you want to allow them to explore and allow them to create their study material in their own way. You also have an opportunity to let the kids upload images they find in the real world, which is a way to show connection. Here we're going to find another Google image, and we're going to type in a specific way to see if what we want comes up. And here's our example of a line segment we're looking through. Don't really see anyone. Here's a good one. We'll use that one. But with some of these you pull up, again, we're engaging the students to design a document to help them to remember names and components. We're exploring. We're allowing the kids to create the creative license to convey their own vision. And we can allow the kids also to explain to show their connection to the real world. Now again, as a teacher, here's one example I wanted to show where you're trying to have a specific image come up. Now, what's the best one you can use to convey the visual definition to your students? Google has some great examples out here. Now, the next one I want to show you, as you're designing with your students, you can do this in class where you show them there are different ways to come at an answer. There are different ways to come at a definition. Now they're looking for an image to put in right here. Now when you put in the first one, this is what I found with Google. It didn't really pull up a good example the first time. When I put in Ray, it gave me one that I've already used before, but we're using that definition for that visual cue for an angle. I didn't find another good example in here for Ray. So this is a beautiful way to show to explore with your kids, to have them come at it a different way. Now you have ray charge, you have stingrays. None of those are like the visual cues you need. So here, instead of typing in ray, you type in line with arrow on one end. See how the students learn? And boom. That's where the explore comes in. That's where the engage comes in. And you can even have them use other arrows they may find in the real world to go through the explanation and connection. Moving on to part 2, the only difference in part 2 from part 1 is that we're looking for different definitions. The format is pretty similar. Here we have the students to identify and define an open figure, closed figure, polygon, right triangle, acute triangle, obtuse triangle, isosceles triangle, equilateral triangle, scalene triangle, hypotenuse, and a leg. There's a link to the Google document, very similar to the other 2 Google documents I've shown you. Again, there are spots in this document where the kids can insert their own figures. Now part 3, again, similar to the other part 1 and part 2, looking for different terms. Students are to identify and define perimeter, degree, quadrilaterals, parallelograms, square, rectangle, trapezoid, rhombus, diamond, radius, diameter, circumference, circle, pentagon, hexagon, heptagon, octagon, nonagon, decagon, and dodecagon. And again, here's a link to that Google document, which is similar to the other ones you've seen. The only difference in part 3, I pretty much let the students pick all the shapes that they want to use. And they can use shapes from the real world. They can use designs they find in Google or whatever they want to do. I just pretty much let them go wild, because by part 3 they ought to be comfortable enough with the computer and its processes to do a lot of this work by themselves. Now we're coming up on the end of the lesson. We're going to call this part Extend. Here we allow the students to redesign their project if they're not satisfied with their first attempt. Again, at the back side of the project, the kids have a larger skill base, so they ought to want to go back and change some of their first attempts because they know more now and they should be more comfortable. And as always, with the end of every lesson comes the evaluation to see if there was a transfer of knowledge. We call this the summative evaluation. Now here's the link right here. This evaluation is similar to the first one you gave the students. It's just more questions. And that's the end of our lesson. Here's my reference page where you can see the standards I used, the books I used, and the other supporting documentation I used to make this lesson. And also, if you want to use flashcards, here's a link I put to an earlier video I made about how to make flashcards. Hopefully it helps. And that's pretty much it for me. Thank you. Continue to look out here. I'm going to try to put videos out here every week or two. Take care and thanks.